friends, in this video we will see basic common base characteristics of the BJT, bipolar junction transistor. So first we have to draw the diagram. So let us see how the diagram will be. So every time we should definitely take either emitter or base terminals or inputs. Terminal, either emitter or base terminal should be input. So if you remember this, you can easily say now. So if you can draw this, let me draw here. So it is a common base characteristics. So the base should be common to both of them like this, and emitter should be input. So here emitter should be left side, and here I am considering PNP transistor. So if it is PN and it is P, then current flows from P to N, so it should be like this. Okay, and for my getting the characteristics, I want to use voltmeters and ammeters. So let me use an ammeter here, and it should be connected to voltage. Even voltmeter is here. So it should be connected to a voltage source, and that we will see later. And here also one ammeter, here also one voltmeter. Now as per the transistor characteristics, we have to apply forward bias to the input. So let me apply forward bias. Forward bias means P should be connected to positive terminal of the supply, and N should be connected to negative terminal like this. Of course, we can use one resistor here for stabilizing the current. That's all, and this should be variable. Same thing happens here also, and here it is P and N. So but here we need to use reverse bias, so negative terminal and positive terminal like this it should become, and it is also a variable. Now we can see, so this is our emitter, so this is our base, and this is our collector. Now this voltage should be VEB. Okay, so voltage between emitter and base. So the second term should be common. Okay, as here base is common, so I am using B as the second term. So it is the voltage between emitter and base. Similarly, this is voltage between collector and base, and this is the current IE, emitter current, and this is IC, collector current. Let me take this one as R1. Okay, so this is the basic circuit diagram of common base characteristics. So now let me circle this. That's all. So this is the way of drawing basic circuit diagram of common base characteristics. Now what are the characteristics? So first we have to see input characteristics. So input characteristics means so generally characteristics means it is the graph between voltage and current. So as the name indicates, it is an input characteristics, so it is the graph between input voltage and input current. But to get this input characteristics, we need to make something at the output side constant. So what we need to keep constant here? So input characteristics means the output voltage VCB is kept constant and vary input voltage VEB and obtain the variation in IE. So this is what we call as input characteristics. Yeah, if you keenly observe this one, this is just like a PN junction diode, okay, giving some voltage to PN junction diode and obtaining the current passing through the PN junction diode. So how can we deal this? So it is, these characteristics are exactly equal to the forward bias characteristics of the PN junction diode, because here also we are giving the forward bias for the input circuit. So let us draw this one. So we can easily draw. So I want to take variation of VEB on x-axis and variation on IE on y-axis, and it is 0. So it's just like PN junction diode characteristics. So if it is 0.1, 0.2 and so on, 0.3, 0.4, 0.5, 0.6 and 0.7. So if it is silicon diode, so it is at 0.7, it should be on. Okay, so now, so the characteristics are more or less equal to like this. It will be like this. So this is one characteristics, but it should be, VCB should be constant. So I can mark VCB constant here, and at one value of VCB I am getting this. Okay, and at the second value of VCB I may get this. Maybe third value of VCB I may get this. Okay, now which value of VCB I am getting like this. So first what I need to do, I need to take one line. If I draw this line, I mean at some value, constant value of VEB, so what will happen? So this value is here, this value is here, and this value is here. So now which value of VCB? It should be high current. So here VEB is constant, and for the same VEB, if VCB is more, definitely the current IE will be more for same value of VEB. So now I can say that whatever the dotted lines I have drawn at the end, that should be VCB more value. So let me take VCB equal to 6 volt, and which is at the middle, this dotted line, VCB equal to 2 volt, and at first line it may be VCB equal to 0 volt. That means as we are applying more and more VCB, we are getting more and more current for the constant VEB. So this is the concept. Okay, it's very simple concept. It is just like PN junction diode only in forward bias. As we are applying forward bias here, so it is working as a PN junction diode in forward bias condition. That's all, very simple. So let's move on to the output characteristics. So coming to output characteristics, so in output characteristics, we need to keep some parameter in the input side constant, and we have to vary the output voltage to get the output current. It's very simple. So now how to do this? For doing this, I want to make input side parameter IE, input current. The input current is responsible for getting the changes in the output side. So IE, I want to make it constant here, and I want to vary output voltage ICB, and I will get the output current IC. Okay, So now I will draw the diagram. So the diagram will look like this. So it is VCB in variation, and it is IC, but we need to keep voltage, I mean IE constant. So but we should know one thing. IE, emitter current, is always equal to collector current plus base current. As we know, base current is very less, so emitter current is always equal to, I mean almost equal to collector current. So if I can take some values here, so if this is, yes, IE is almost equal to IC, so here I want to draw IE. This is IE, value of IE, so it is almost equal to, so I have taken IE is equal to 1 milliampere, and it is exactly equal to IC. Okay, almost equal to IC, you can see here. And if I take IE equal to 2 milliampere, so which is equal to IC, 2 milliampere, and if I take IE equal to 3 milliampere, it is equal to like this. And if I take IE equal to 4 milliampere, so IC is also equal to 4 milliampere. So these are the output characteristics of transistor in common base characteristics. Okay, now what exactly happens here? So VCB is reverse biased in nature. So let me take its value -1, -2, -3, and -4, -5. As VCB is increasing, IC should also be increased, because even though IE is constant, IB is also almost keeping constant. So IC will little bit, there is a little bit increment in IC. Okay, even when compared to IE also, there is a little bit increment in IC. So this is called early effect. Okay, but it is almost negligible if we use VCB in a small steps. Okay, if you have huge VCB change, then only we can able to recognize the change in IC when compared to IE. Okay, so this is the concept. But here we need to understand one thing. Even though VCB is 0, IE never 0, IE never be 0, sorry, IC never be 0, because there are some charge carriers. So then how to make this IC 0? So to make this IC 0, you have to do, yeah, so till now we have applied this. Yes, so till now we have applied reverse biased voltage condition at VCB. So for getting IC equal to 0, so we need to apply voltage in the reverse direction. So at 2 we are giving in reverse direction only, but now it should be again reversed. That means we need to provide forward bias voltage here. So if this is +1, so within +1 only everything will come and make the IC 0. So if you give a small amount after 0, if you provide a small amount of forward voltage, so this line will come like this and making it 0. So similarly this line will come like this and making it to 0, and similarly this line also coming like this and it will reach 0, and this line also coming and it will reach 0. Okay, so this is called output characteristics of transistor in common base characteristics. And here we need to note one more thing also. So from here to here, where the VCB is in reverse bias is called active region. That means this is the area we can operate our transistor. and where we are providing forward bias to VCB, then that is called saturation region, this part. Okay, so after in saturation region only our IC will be coming to 0. So I will write this fact here. So active region means, in active region VCB is in reverse bias, and in saturation region so VCB is in forward bias. So this is the fact we should learn from this characteristics. Now let's move on to the current gain characteristics. So current gain characteristics. So coming to current gain characteristics. So here current gain characteristics means we need to draw the characteristics between two currents, input current and output current. So let us see how it will be. So it should be, one thing should be constant here. So I want to make VCB as constant, and I want to see the variation of IC with respect to IE. That means I will vary IE and I will capture the variation of IC. So here let me keep VCB constant and I will vary IE and I will capture IC. So this is what the characteristics are. So now this can be captured. So this can be captured by using output characteristics also. Okay, so that generally these two characteristics are, these two characteristics can be drawn side by side or within the same graph. Okay, so that part I will show you now. So how to draw these two graphs side by side. For this I want to capture the same thing and I want to take right side. You just observe. So I'm simply dragging this to this current gain characteristics. That's it. So now how to draw this we will see. So this should be extended like this for clear clarity. Okay, I will take these values, and this is, if this is +1, this is 2, and this is 3, and this is 4. So now how it will be? Okay, I can simply, I will take these 1 2 3 4 into right side. So now this is IC and this is IE. Okay, the left side part is IE. So IC and IE, so these two are combined like, so this part is not correct, this 0 is not here, and the 1 is here, 2 is here, 3 and 4, that's all. Yes, so IE and IC are almost same. So if IE is 1, IC should also be 1, so the point will come here. Similarly, if IE is 2, IC is also equal to 2, so the point should come here. If IE is 3, IC should equal to 3, so the point should come here. If IE is 4, IC should equal to 4, point should come here. So if you join these lines, you will get characteristics. Okay, it's a straight line actually. If it is not looking like that, I am extremely sorry, but it is a straight line, it should be like this. Okay, then how to capture from output characteristics? So these are the output characteristics. Then how to capture current gain characteristics from output characteristics? Okay, So to capture this, so we need to identify fixed VCB. So let me take VCB equal to minus 2 volt. Then just drop a line on top of it and identify the values here. So for example, this is the value at IC equal to 1, and maybe this is value at IC equal to 4. Then drop the same values here. IC equal to 4, so get the same value for IE equal to 4. Similarly, if it is IE equal to 1, get the same value with IE equal to 1, like this. Okay, then take these 2 points and based on these 2 points draw the line. Okay, so this is the way of drawing current gain characteristics from output characteristics. Okay, in some time it is showing like a small increment in IC also. At that time these lines differ. Okay, maybe these lines may come like this, one line may be like this and second line may be like this for various VCBs. Okay, for different VCBs, these lines are different, a little bit change will be there. So the change will be very minute, and if VCB equal to 2 volt, this may be the characteristics, and if VCB equal to 6 volt, and this will be the characteristics. Okay, the change is very minute. I have shown some wide range here, but it is not like that. They are almost similar and almost same. Okay, and these are the things, and I forgot to explain one thing. Even this is saturation and this is active region. Even we have breakdown region also here. After some time it will be like this. So this is called breakdown region. Generally in output characteristics, breakdown region will be shown. Breakdown, so there are two reasons for breakdowns: general PN junction diode breakdown is there, junction diodes breakdown is there, it's natural and it is like this. Okay, what we have shown in the diagram. And there is another breakdown that is called punch through or reach through breakdown. So what does mean by punch through or reach through? So punch through or reach through means, so this is a transistor, this is some PNP transistor, so we have considered this, PNP transistor. So this is the base, emitter and collector. So of course we have mentioned this is forward bias and this is reverse bias. Okay, this is what we have seen here also. Okay, same characteristics. So what happened if it is a forward bias? Forward bias means the forbidden band or the depletion region is very small like this, and but reverse bias in this junction. So this is called emitter base junction and this is called collector base junction. So in collector base junction, because of reverse bias condition, the depletion region is wider like this. And if you keep increasing this value, so it is further wider because we are increasing the reverse bias voltage, further wider. And if you keep on increasing after some specific value also, this is becoming wider and finally reaching this emitter base depletion region. So this collector base depletion region reaching the emitter base depletion region. At this time, huge collector current will flow. Okay, so this condition is called punch through effect or reach through effect. So this effect is very important. Please make a note of it. Okay, so this come under breakdown only. At this stage, huge collector current will flow and it can damage the device also. Okay, so thank you so much for your careful listening, and please like this video and share this video with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.